Right, it is the top of the hour. So welcome everybody to today's webinar, which is on the subject of prior use justification and how to achieve it. So this is a topic that comes up regularly when teaching the classes or when discussing with clients. So hopefully by the end of this webinar, you will have a better idea of why prior use justification is required and how we would go about achieving it. So just before we begin that, I just want to take a safety moment here to remind everybody that when we deal with functional safety, we have to avoid the temptation to take shortcuts to get up and running. This is always a problem when projects become a crunch and there is a rush to get finished so we can get the safety instrumented system up and running. We have to be wary of that, and we have to make sure that we don't allow this to happen, because what can happen, of course, is that systematic errors can creep into this. And therefore, we could end up having some issues further down the line that could lead potentially to some form of incident or accident. And we know that these can be very expensive. So we must make sure that when we're looking to be successful, we cannot take shortcuts. So that's just the thing to remember with functional safety that often gets overlooked when it's crunch time. I'm Steve Gandy. I'm not going to talk about myself too much. Some of you probably attended my webinars before. Those of you that haven't, welcome. I've been with Exeter for now 13 years, and I've been in industry since 1977, so it's a lot of years now. Exeter itself, the company's been around now for 25 years. It was originally started by two gentlemen. One was American, Bill Goebel, and the other one was German, Rainer Faller. Bill Goebel was the customer, Rainer Faller was the vendor. And Bill went to Rainer, who was at TUV at the time, to get his new system certified to what was then the new IEC 1508 standard, which is now, of course, 61508. And as Bill likes to say, he failed miserably and, of course, said to Rainer, okay, what do we have to do to fix this? And Rainer said, well, we don't do that. And then they sort of had an aha moment where they realized that other manufacturers would be in the same boat. So that's how Exeter was started. And Exeter actually stands for Excellence in Dependable Automation. We've grown exponentially since then. We don't just do the certification for functional safety, we do certification for cybersecurity and also personnel certification. Some of you may even be CFSE or CFSP qualified. We've also started the Lifecycle Services division, which provides full lifecycle services for alarm management, cybersecurity and functional safety, including all the relevant training and documentation support to go with it. And we also have a third division which deals with our software tools, the Excellencia tool. Some of you may be very familiar with the Excellencia software tool. We also have grown from just the two original offices. We're global. And the nice thing about the three disciplines, the functional safety, the alarm management, and the cybersecurity, is it's what we like to call industry agnostic. You can apply it to any industry. So we've worked in mining, we've worked in pharmaceutical, food and beverage, oil and gas, chemical, machinery, etc. One thing I do try and encourage people to do is to make use of the Exeter.com website, because there's a reasonable amount of material there. Most of it is free in terms of these webinars, which are recorded as YouTube videos, also the papers that we publish and case studies. And if you need it, you can also purchase the books that you see here. The Excellencia tool allows us to do the full life cycle support. So we can do the hazard and risk assessments all the the way through to providing the life event recorder. So you can record all the safety instrumented system performance data as well. I'm not going to talk too much about that because I want to get to the meat of this, which is, of course, what is prior use justification and how to achieve it. So this famous pie chart, which has been shown multiple times over the years, was the result of an investigation or study that was done by the Health and Safety Executive, firstly in 1995, but then again 8 years later in 2003. And what they looked at was the causes of accidents involving control systems and safety systems. And as you can see, the majority were down to the fact that specification. So if we get the specification wrong, and design and implementation isn't going to be much better. But also, as you can see at the back end, when you get into operation and maintenance and commissioning, there's a further 35%. And all of this stems from systematic failures. And when they repeated the study again 8 years later, these percentages hadn't changed too much. And over the years, again, they've not really changed that much. And it's very interesting that despite all of this, sometimes people do not spend the time and effort to make sure the specification of the safety instrumented system is done properly. Now, when it comes to the IEC 61511, it's based on a life cycle. And here again, it's different from previous standards since it's not prescriptive. So a prescriptive standard would say this is what you have to do and this is how you do it. There's no leeway. Whereas with a performance-based standard, it will say this is what you have to do, but how you do it is up to you as long as you can measure your performance. And with 1511 and 1508, they are both performance risk-based standards. Now, the major authorities, COMA in the UK, OSHA here, requires operators of hazardous processes to follow best practice, or RAGAGAP. RAGAGAP being recognized and generally accepted good engineering practice. So 1511 and its equivalent, the ISA 61511, is recognized as being RAGAGAP. And they're both based on a safety life cycle. So it's not a once and done, there are ongoing requirements. And there are 3 phases. There's an analysis phase. This is where we're analyzing the requirements for the safety instrumented system to help us mitigate identified hazards and make sure that we have sufficient risk reduction in place to meet our tolerable risk. And then, of course, we have to design and implement. And once we've done the design and implementation, then we have to install it and operate it and maintain it. So there is a cycle, a life cycle. And of course, when it comes to not just the analysis, design, and implementation, it comes to the overall operation and maintenance. The success is going to be based upon culture. So if the company culture is one of minimizing expenditure and maximizing operating profit, then this can be at odds with making sure that we properly implement and maintain functional safety. So the objectives of the life cycle are really to help us build safer systems that don't experience a lot of the problems of the past. The thing about prescriptive standards is you can be compliant with a prescriptive standard, but you may still have a gap between what the prescriptive standard gives you and what your actual tolerable risk as defined is required. It also helps us make sure that we have cost-effective systems that do match the design with the risk, because the life cycle is all about balance. If we get it right, it will work out well in the end. We may spend more time and effort up front, but that will save us time and effort at the back end. Because if you're old enough to remember the old 20-20-20 adage, it was 20 weeks in design, 20 months in implementation, 20 years in operation. So the majority of the life cycle time for the SIS, the safety instrumented system, is going to be spent in the operation and maintenance part. So we can design it properly, we can implement it properly, we can install it, commission it, everything's great day one, but if we don't maintain it and don't follow what's required from the functional safety point of view, then of course our performance is going to drop off a cliff. So the objectives of the safety life cycle are help us minimize the systematic faults that can creep in. And systematic, if you like, can be characterized by what we call the 3 Ps. So the first one is people. Do we have properly qualified and competent people to make sure they know what they're doing? The second one is procedures. Do we have well-defined written procedures that are being followed? That's the key part of that, because many accidents are the result of procedures not being followed properly. And thirdly, do we have a paper trail to prove that we're doing what we said we were going to do and we're doing it right? And then secondly, to avoid the potential for random faults creeping in. If we look at the life cycle, as I said, there are 3 phases: the analysis, the design and implementation, the operation and maintenance. And we're going to focus here on the SIS design and engineering and how we qualify the equipment that's required to be used in the design. This is where the prior use justification may apply. So if we look at this in more detail, the 1511 standard requires us to justify the equipment we're using in our safety instrumented system and our safety instrumented function designs. So this is very important. And the purpose of this is to make sure that we are meeting the systematic capability for the particular device. So when it comes to performing the SIL verification, there are 3 things that we have to meet with SIL verification. Firstly is, do we meet the random target? The random target is going to be our PFD average or our PFH if it's high demand or continuous. Then we have to meet the architectural requirements. This is where we determine whether we need voting for redundant architectures, for example. And thirdly, we have to meet the systematic capability. So it's not a 1 out of 3, it's not a 2 out of 3, it's a 3 out of 3. So we have to meet all 3. So systematic capability is very important, and IEC 61511 gives us 2 methods for qualifying the equipment to be used in a safety instrumented function. And that is, we can either use 1508 certified devices, or we have to do the prior use justification. Now, in 1511, it talks about prior use. In 1508, it talks about proven in use as a means of meeting the SIL requirements. They're essentially the same thing. The only difference is that proven in use is based on manufacturer's design basis in terms of how they've designed it for the temperature limits, the vibration limits, any corrosion limits, desired maintenance support, etc. for the device. So it's more device specific. Prior use deals with the device's installed performance within a particular process sector, and of course that's the application as well as the operating environment, which is often different from that as a manufacturer's design basis. So this is the difference between the two, and as I said, in 1511 it refers to prior use. So the only 2 methods that we have is to use 1508 certified devices to the relevant SIL capability, or if we haven't got a certified device, then we have to do a prior use justification. And remember, because people often say to me, if I take a SIL2 sensor, a SIL2 logic solver, and a SIL2 final element, I should have a SIL 2 SIF. No, not necessarily, because you have to consider from the sensor to the final element and everything in between. So it's tip to tail and everything in between. So if we're using, for example, interposing relays, then those relays need to be certified. If not, we have to do a prior use justification. Similarly, if we've got splitters, if we've got Zener barriers, if we've got positioners, motor controllers, etc., we have to make sure all the equipment is properly qualified in terms of the SIL requirements. If we have equipment that's not certified, then we have to do the prior use justification. So what does that mean? So when it comes to the justification, we have to remember that it depends upon not just meeting the safety integrity level requirements, but it also has to be suitable for the application. So this would be in terms of the operating profile, temperature, pressure, etc., as well as the materials, the process materials. So if we've got corrosive process materials, then we have to make sure we select equipment that is suitable for that application. So both of these have to be considered, and then we have to document the justification. With 1508 devices, it's easy because we can use the certificate to justify the selection. But if we haven't got a certified device, then of course that makes life more complicated. So from the application point of view, again, as I've said, we have to make sure that the materials are compatible with the expected process conditions, but also, does it perform all the required functions? And is it rated for the expected environment in terms of temperature, etc.? It's very important, and anyone who's been on the RFSC 100 that I've taught will remember that I always go on about the safety manuals. It's very important that you have the safety manuals, because the safety manuals will include important information plus any restrictions, especially if it has that nice word capable. What does it mean? If it says the device is SIL 2 capable, what does that mean? And it may mean that you have to have two of them, and they may have to be configured a certain way. So the safety manual is very important. So if we're using certified devices, we purchase certified devices, we should always make sure we get the safety manual. Now here again, 1508 says the manufacturer has to have a safety manual, but it doesn't say they have to provide it free of charge. So you may end up having to purchase safety manuals or part of safety manuals. It just depends upon the particular manufacturer and what they do. So 1508 certified devices is the easiest way to justify the equipment use, as long as it meets all the other things that are mentioned here. If we don't have a certified device, then we have to perform a prior use justification. And the purpose of prior use is again to demonstrate the SIL capability of the device based upon previous operating experience. Now here, when we talk about operating experience, it has to be in similar operating environments. So are we comparing apples to apples or apples to oranges? And this is one of the issues when it comes to prior use. Sometimes people say, well, I've had this device and I've been using it for years and I have all this data. But the problem is the device that they have the data for is not the same version as the device that they're trying to get prior use justified. So here again, we have to make sure, is it similar in operating environment? Because the primary intent is to make sure that we have sufficient evidence to prove that the dangerous systematic faults have been reduced to a sufficiently low level compared to the required safety integrity. So that's why we have to do the prior use. Because if we use non-certified devices, it won't meet the systematic requirement. So the SIF may meet the SIL target for the PFD average, and the architecture, but it won't meet it for the systematic. And this is part of the problems that we come across, especially with legacy systems. So we have to make sure that the dangerous systematic faults have been reduced to a sufficiently low level, and also we have to make sure we meet the random failure requirement, which of course is to perform our PFD average calculation or our PFH calculation. So we have to do that as well. 1511 does list items that have to be included, but they don't give many details on what's sufficient for a given SIL. So this is left to interpretation. Because of the issue of comparing apples to apples rather than apples to oranges, all the devices have to be identified with a specific revision number, not just the hardware, but if it includes any firmware, the firmware revision has to be included as well. And we have to demonstrate that all the devices are under the control of a management of change procedure. If we have any fixed programming language devices, these would be sort of devices where you could set ranges or alarm limits, etc. in a panel. Those will have special SIL3 application prior use requirements, and you'd have to go and look into what was required. For devices that have limited variability language really applies to application programming. So in other words, if it's a PLC, then we can only prior use justify for SIL1 and SIL2 with a number of additional requirements. The other thing is the clarification on the issue of device engineering changes. As I said earlier, we could have two devices that have different revision numbers, and if we don't have sufficient data for the second device, then we have to look at what is the change from the first version and how significant is the change, because the prior use could be invalidated if it's a significant change. So we have to track that and make use of it. So there are 4 key items that 1511 requires us to investigate when it comes to prior use justification. The first one it talks about is consideration of the manufacturer's quality management and configuration management systems. So that's a bit of a vague statement. What does that mean? And we'll talk about that in a minute. Then it talks about having adequate identification and specification of the components or the subsystems that we're using. So again, adequate is a bit of an open to interpretation term. So we have to consider what we mean by adequate, and then demonstration of the performance of the components or subsystems in similar operating profiles and physical environments. This is very important to make sure we're comparing apples to apples and not apples to oranges. And then finally, it talks about the volume of the operating experience. So again, what does that mean? That's open to interpretation. The thing to remember here is when it comes to the extent of the manufacturer's quality audit, this is where we have to look at how well is it documented, and of course the identification requirements as well as the volume of operating experience. So these things are not necessarily stated clearly, and as I've said, are open to a level of interpretation. So what does this mean in practice? Well, what it means in practice is that we have to have good, accurate, and properly maintained records. So this means that we have to have a quality data, field data gathering system. So in other words, how well have we tracked any field failures? Have we done the root cause analysis? The operating environment and application must be similar and justifiable. So for field devices, we're looking at the behavior of the device in operating environments And it can be either used in safety or non-safety. If the operating environment is the same, then it doesn't matter if it's in safety or non-safety, as long as we have the relevant documentation and evidence to support this. When it comes to the investigation and root cause analysis of failures, this is important, and this is where oftentimes the systems break down because, yes, some end users may do investigation of failures, but do they know to determine whether the failure was initially safe or dangerous? And typically with dangerous failures, we can either usually find those through the use of proof testing or the combination of diagnostics and proof testing, or because we had a failure on demand. So we need to know, was it a safe failure or a dangerous failure? And then if it was, whether it was random or systematic. And this is another area where it's very grey and people are uncertain how to do that. So we have to have a good quality field data gathering system. And in 1508, it identifies a couple of standards that you could use. And there's the IEC 6300 or there's the ISO 14224 standard for gathering field data. So basically what we have to look at is our field failure records to see, did we have any dangerous failures over the past year or so? And if we did, were any of those attributed to or could be attributed to systematic issues? So this is what we would have to do. And as you can imagine, it's not that easy. When it comes to the device usage and performance here, the list that can be used to support the claims needs to be updated and monitored regularly. So here we're back to how well are we keeping records. Field devices are only added when sufficient operating experience has been obtained, and then field devices are removed when they show a history of not performing in a satisfactory manner. Now remember, this is for devices that are not certified, where we're trying to do our prior use justification. So the operating environment is included in the list where relevant so that we can make sure, because for prior use, we can use non-safety applications to help justify if the operating environment and the application is the same or very similar. Device performance is going to be affected by the operating environment, as we know, so the selection of the devices will need to be based upon the adequate performance of an installed sufficient number of devices in multiple installations for sufficient operating time. So here again, if you're familiar with statistics, we have to have a large enough sample and it has to be very relevant to what we're looking at. This is the same thing. Do we have enough information that can be statistically relevant? And of course, are we looking at the same profile? If it's longer operation, those can help reveal failures, of course. And most of the time, this could be related to the specification, handling the installation, and so forth, where we could introduce potential random and systematic problems. So the purpose is to have enough operational experience to gain that credible statistical reliability data. So of course, that's going to be typically higher compared to operational experience necessary to get that evidence of prior use. So how can we do this in a more practical way? 1511 doesn't give you a defined time in use when it comes to doing the prior use justification. So what we tend to recommend is that the equipment or the item must have been shipping for at least a year without any revisions or changes. And it must be, again, shipping for longer time without significant revisions or changes. If there are changes, then again, as I've said, we have to look at the significance of the change to see, is it a minor change where we can justify the fact that we can use that data, or if it's a major change. 1511 doesn't have a defined operating experience, so again, what we recommend is about 30 million hours of estimated usage should be obtained from a minimum of 10 different applications, which have similar stress conditions and so forth relevant to what we're looking at. Our prior use criteria has been derived from both 1508 and 1511. So this would give us significant hours to be able to demonstrate we have the data. And again, as long as it's relevant to what we're looking at in terms of the profile, then we can use that. But again, we have to make sure that we have good records, especially if we've incurred failures and we've done the proper analysis of the failures to determine, again, was it safe or dangerous? Was it random or systematic? So the approach will give us a practical and quantitative guideline on how to assess. And we do actually have in the Excellencia tool a prior use checklist that can be used. So when it comes to estimating the number of hours in use, and this is often a problem as well, especially with legacy systems, we don't necessarily know how long the equipment's been installed and when it was installed. Again, sometimes people just consider the shipping dates, but that assumes then as soon as you ship, the clock starts, which of course is not the case, because it can be shipped to a warehouse, it could be sitting in a warehouse for a while, there could be spares, we don't really know. So in that case, if the actual installation dates are not available for the hours in use estimation, we can make certain assumptions. So we can assume, for example, the installation occurs 6 months after the equipment item is shipped. So as long as we're using reasonable assumptions that we can defend, then we'll end up with reasonable results. What we don't want is overly optimistic results, because all that will do is lead us into thinking, again, we have a more reliable device than we actually do. If the equipment has a wear-out mechanism, we mustn't exceed the useful life. And here again, with legacy systems, this becomes a problem because we don't necessarily know whether or not we've exceeded the useful life of the equipment. And here again, when it comes to prior use justification, we have to make sure it's within the useful life. We can assume that no wear-out failures are reported to the manufacturer. This is, of course, a worst-case assumption, as wear-out failures will be considered as random hardware failures. So here again, how does the manufacturer know how many devices have actually failed? And of course, especially when they get outside of warranty, because depending upon the device, if it's a relatively low-cost device, like a sensor, the end users will probably just replace it, and the manufacturer will not be aware. So this is another thing when manufacturers try to do the proven in use justification for their devices. So just to summarize then, the majority of the accidents that occur are usually traced back to systematic issues. And when it comes to the equipment, we have to make sure that the equipment, as far as possible, has been designed, installed, and implemented in a way that helps minimize the potential for systematic issues. That's why, of course, if we're using certified devices, we know through the certification that there's a level of rigor that the manufacturer has applied to how they initially specified, designed, tested, and manufactured their device. So we have that confidence. When we don't know, or we have a non-certified device, we don't know how the manufacturer designed it and whether or not they did follow a proper quality system, such as an ISO 9001, for example. So again, coming back to regulation, regulators require end users, of course, to follow RAGAGAP, recognized and generally accepted good engineering practices, and of course, using one of the performance-based standards such as 1511 requires us to do this selection and justification of the equipment that's being used in safety instrumented systems and safety instrumented functions, and that they meet the required systematic capability. And as I said to you, when it comes to doing SIL verification of the safety instrumented function, we have to meet those three requirements. We have to meet the PFD average target or the PFH target, depending if it's low demand, high, or continuous. We have to meet the architectural requirements, and we have to meet the systematic capability. We don't use certified devices. We will not meet the systematic capability without doing the prior use justification. So those are the only two methods that 1511 allows us to use to justify the equipment. Are we using 1508 certified devices? Or if not, can we do a prior use justification? So those are the only two methods that we can use for justification. And of course, mechanical integrity has to be maintained, and we have to be monitoring the useful life. That's why I said to you, oftentimes with legacy systems, it's very difficult to establish whether or not the equipment has exceeded its useful life. Because unless we know exactly when it was installed and we've been tracking it, it'll be very difficult to do that. And of course, even with prior use justification, we still have to make sure the equipment is within its useful life. So it's not necessarily an easy and straightforward route to be able to do prior use justification. That's why, of course, wherever possible, we should try and use certified devices. So remember that for prior use, we have to have sufficient volume of operating experience in terms of the number of hours in operation, and the equipment has to be operating in a similar application environment. As I mentioned, it doesn't necessarily have to be used in a safety application, but we can apply, as long as the environment is the same, we can utilize the hours. And of course, the devices are the same version, or if they're different versions, we have to assess what's the difference, because it may null and void us being able to use the previous operating experience. So prior use will require us to track the versions to make sure, as I've said, it's based on the same version, or if it's a different one, how different is the version. And we have to also consider certain assumptions regarding the in-service operational time for the equipment. As I said, these are some of the challenges as well, depending upon how well we've been documenting our field failure and field operational information. So operating profile has to be similar so we can justify it. And 1508 does provide some good guidance on the operational requirements and hours. As I said, Exeter, if people want us to help with prior use justification, we have certain criteria to make sure we meet those four things. Is the manufacturer's quality system up to speed? Have they been following it, and so on? Are the version numbers properly recorded? Can we prove that it's a similar version? Of course, the volume of the operating experience and use in the same operating profile. So these are all very important things to be able to justify a prior use device. That's why I always tell people, wherever possible, use certified devices, then you don't have necessarily the worry of the systematic side of things. But if we don't have certified devices, the only other way is to do the prior use. Otherwise, the SIF will not achieve any SIL. Okay, so So hopefully that's given you a clearer picture. and we can take some questions. Let's see what we have here. Let's see, I've got a couple of questions here. Are Exeter going to issue a new version of the SER which shows generic data? I think it's volume 4. I believe so. I don't know where it is, because that's the certification side of the business. If a device is 61508 certified, let's say SIL 3 capable, does it mean that it is proven in use by the manufacturer? No, if it meets the systematic capability, that means it meets the 1508 requirements for being able to be used in a SIL 3 application. So certification is going to be a different method and route rather than doing the proven in use. And it says, for a SIL 2 SIF for a motor emergency shutdown, we can ensure SIL up to imposing radios, but SIL rating for motor contactor breaker not usually available. Also, as per 1511, prior use justification for them is not easy to claim because, yeah, and I agree, it's not easy. So we have to have a means of being able to do that. Now, there are some certified MCCs now, so that might be an easier route to go. Your challenge is made more difficult if you don't have the field failure or the field records, and they have to be accurate. So this is part of the problem with a lot of the systems that are being employed. Unless it's following one of those standards, the 6300 or the ISO 14224, it's going to be very difficult, again, to prove that you've got quality field data that you can rely on. So there are a number of things that would need to be looked at. How can we ensure SIL compliance by cable termination, such as cable termination in transmitter and in the junction with Wilton and Marshall and Cabot? Well, again, see, part of the overall system, and if you use Excellentia, it does take it into consideration. The contribution to the overall PFD average, when you're looking at cables, etc., is going to be pretty low in comparison to the final elements. Now, from the systematic point of view, this is where we come back to, are we using properly qualified and trained people that are following written procedures when they do the installation and the cable and the testing? Because again, if we haven't got qualified people, then we're going to have a potential systematic issue. Because remember, systematic is about the 3 Ps. And the first one is the people. The interesting thing is in 1511 now, when they made the change in 2016, they put far more emphasis on competency and making sure that people are competent and that there are competency records, and we're tracking the competency because it's been an issue. What exactly is the basis for the time in use recommendation of 1 year? Well, again, it's just trying to take a reasonable view. So saying 1 year without any major changes and any revisions for the 2-year period, because over 2 years they may make a change. Now, again, is the change significant or is it minor? And a lot of this is going to be based on judgment, of course, because it's going to be looking at it from a qualitative point of view, and that's why I say when you read those requirements, they're open to interpretation. What we try and do is give some guidance based on our experience and knowledge and understanding, so that we can have not overly conservative, but we have reasonable numbers. In your experience, has any client or contractor elaborated a prior use justification? How long it took? Have you helped? Yes, we have. We've got instances where it's taken 6 months or more. Because here again, if the end user doesn't have the field experience with the device, then they would have to go back to the manufacturer. And the manufacturer, if the manufacturer is willing to help them, if they're a big user of the manufacturer's device, then that's great. If not, the manufacturer may not unless he's paid to do it. So it's not necessarily the easiest route to go. And it can take a significant amount of time. This is part of the problem. Is there a recommended list of what information? Yes, there is. We have a recommended list on that. What is the source of 30 million hours of estimated usage prior use justification? Again, if you ever did statistics, you've got to have a large enough sample to be able to be statistically relevant. So 30 million hours is a reasonable amount of time. And again, depending upon how many devices are installed and for how long, that shouldn't be huge. Paul Grunbook says different figure in the range of 100,000 hours. Well, again, it depends how you want to look at this. Because what we don't want is we don't want overly optimistic numbers in terms of what comes out of all of this. So if you choose to go low, you've got to be able to justify that you have sufficient number of hours. I said, most of our recommendations come from 1508, 1511. Apologies, I missed some of the webinar, so can systematic capability deemed reliable enough? Well, I don't like the term bypass. Systematic capability can be justified if we can meet the prior use criteria. And then it says a non-SIL rated equipment can be found within a SIL rated loop if found to be reliable enough, or is it prior use method making selected failure rates credible and justified? But here again, as I said, prior use, the primary purpose is to prove that the contribution to dangerous failures from the systematic point of view are low enough with a given SIL, but we still have to make sure we meet the random failure requirement. And the random failure requirement is the PFD average or the PFH. So in order to do that, we would normally perform a FMEDA, failure mode effects and diagnostics analysis, to come up with the numbers, or we would use generic numbers. Because in 1511, there's clause 1193 that says the failure rate data used for your calculations has to be credible, traceable, documented, and justified. So here again, we have to be using realistic failure rates for the device. So we not only have to do the prior use from the systematic point of view, we have to do the calculation. So we have to make sure that the failure rates also are credible. Not sure if this strays too far away from the topic, but is root 1H safe failure fraction commonly used within industry, or is it seen as bad practice compared to 2H? Well, that's a very interesting question, because you can still, 1508 still has root 1H and root 2H in there, so you can use safe failure fraction, as long as you're not playing games with no effect failures, because again, all you're doing is fooling yourself. You can use it. It's really a question of, for the 2H, remember that 2H, the purpose of 2H is to allow you to reduce your hardware fault tolerance by 1, provided you have 90% plus accuracy in the field failure data. And according to 1508, you have to be using a field recorder that meets either the 6300 standard or the 14224. If not, you're going to have a hard time proving. And this is one of the things when you look at the 1511 table for the hardware fault tolerance for the given SIL, it says that hardware fault tolerance of 0 can be used for SIL 1 and SIL 2 and in low demand. And that table in low demand is exactly the same as the 2H table in 1508. So most of the time, people will probably use the 1511 table, and you may start off, for example, if you're looking at a SIL 2 design, you may start off at a hardware fault tolerance of 0, but you might not end up there. So you can use both. And the thing about 1511, it allows you, it says specifically you can either use the tables in 1508. So if you know if it's a type A or type B and you've got a safe failure fraction, you can go 1H. Or if you know it's 2H, then you can use the 2H table. Or you could use the 1511 table. Can a device be certified to SIL 2 based on prior use justification? Yes, depending upon the device. As I said, if you've got a logic solver, you're limited to SIL 2 as a maximum under the prior use justification. What is the restrictions of using data recorded in different location and use in different location? Well, again, it doesn't matter as long as you're comparing apples to apples. In other words, is the operating profile the same or not? 30 million hours is a lot of hours. Yes, it is. But again, if you've got dozens of the devices, then it's not going to be too bad. Who will perform prior use? The prior in use by manufacturer, end user. It has to be somebody who is competent to do that. Manufacturers can do it because manufacturers can do their proven in use. And again, who perform the SIL verification activities? As long as that person or company is competent to do it. So people like us would do that. But you can do it yourself as long as you've got competent people qualified to do it. For prior use, what are the ways to obtain the PFD for the equipment? Do we have? Yeah, you can use FAMIDA to do that, or you can do an equivalent as long as you can prove that you're using the right information, or you can use generic. So we have a lot of generic information available. Can this presentation be shared? No. It's recorded, so you can obviously view it again if you want. In justifying a device for prior use, is bench testing the device necessary or is justification possible? Remember, we have to do two things with prior use. We have to prove that we can meet the random hardware failure requirement, which is the PFD average or the PFH, so that would be through a calculation, and we have to meet the systematic capability. In an application where temporary infrastructure will be installed with safety functions, so only being can do the prior use method requirement will change because it's temporary. Well, no, because even if you're running just for 6 months, you're still going to have the hazards present and you're still going to have the systematic issue. The specific non-certified electrical component, there was a total operational experience based on available MMTBF can be used to derive failure rate and assuming 50%. Well, you could, as long as you're comparing apples to apples. But don't forget, you've still got to get you've still got to do the systematic review. Passive devices required to be certified? No, not necessarily, no. Channel blocks, no. What are your views on use of generic failure data for use in? Well, again, you can use generic failure rate data for PFD calculations because they're slightly more conservative, but again, generic won't meet the systematic. And if you choose to ignore systematic, you have to have a good justification for doing so. So We have failure data and PFD calc as a general group of sensors. Not having IEC's 1508 safety manual. Well, as I've said, with generics, you can use that for the PFD calculation, but it won't get you the systematic. Do just the required operating time, taking into account maximum SIL used as reduced for SIL 1 if so by what proportion? Well, we do have certain guidance on this, and again, we're happy to help wherever. Please elaborate more on 30 million. It seems too much. No, it doesn't seem that much when you're dealing with safety. If you want to know more, please contact me. Assume I can provide a full prior use assessment fulfilling all the shown requirements in terms of completeness, consistency, documentation. I've calculated the failure rates as well. How can I decide whether this item has an equivalent systematic? That is, how do I decide if I can use it in a SIL 1 rather than the SIL 3? Well, that's the guidance on that. SIL 3 anyway, if you're going to do SIL 3, you really need to meet 1508 SIL 3. We can help with that, of course. For the non-certified equipment, especially electrical ones, such as low voltage breaker, the failure rates provided in the database like SINTEF could be accepted, used to validate the CIF, as long as they meet. So, for an example, we ended up publishing a website called SIL-Safe Data. It's free. If you go to SIL-Safe-Data, it's all one word, .com, you'll see that there's a low bound DU failure rate number and an upper bound. And it's not just based on Exeter data, it's based on what's publicly available. So again, you can look at the numbers and see, do the numbers fall within the SIL-Safe limits? If they do, fine. If they're not, then how far out are they? So you need to be careful with that, because that's why that clause 1193 was put into the standard, because there were people publishing failure rates for actuators with half a fit, which is ludicrous. So you've got to make sure, and if in doubt, contact us. Who can perform a proven in use study? Well, the manufacturer can do, you're talking proven in use, not prior use. The manufacturer could do that, or somebody like us could do that, as long as whoever does it is qualified. If the mean time to fail dangerous is high enough. What does that mean? Not sure what you mean by that. Or prior use study. No, I'm not sure what you mean by that. So if you want to drop me a line and let me know what you mean by that, I'll be happy to answer it. Good questions. I appreciate that. Obviously, we're nearly at the end of our time, but again, if you need help with any prior use justification, please reach out. I'm happy to help. Just let me know. Okay. Well, I thank you all for attending and for your very good questions. If you want to ask me questions specifically, my email address is there, as you can see. And if you need help with anything, we'd be happy to do that for you. Just let us know. So thank you all. Appreciate your time and questions, and look forward to you attending a webinar in the future. Thanks a lot. Bye for now.